Okay, I think we got it. Copy. Okay, looking good.
All right, thanks.
Yes, so, hello everybody. For the last two talks, first one is from Angelo Bresto, talking a bit about Wi-Fi and applications for IoT.
Great. Thank you. Hi folks, I appreciate you being here. It's the basement after the last break of the day, so just by being here, we're making history. The talk's going to be on the first mile, and what that means is the very edge of your data collection. So bringing in information from Internet of Things, certainly, connected vehicles, from sensors and small or embedded devices, places where you don't generally get a really good grasp of data very easily. And then how do we bring that in and feed it into systems that can make sense of that data? So brief agenda, obviously an introduction around the topic and some introduction to data flow concepts. While these are not very complicated, they can have different terminology, and I just want to make sure we're all on the same page for what we're going to talk about today. I'll talk about Apache NiFi briefly. Apache NiFi is the top level project here, and then Apache Minify is the sub-project, which is focused around this edge data collection. Unfortunately, I'm not doing a live demo today. TSA does not like my Pelican case full of loose wires and components that look sketchy on airplanes. So I do have some videos of stuff, and I can show you those, and then I can, I can go into further detail after the session as well. So just to get audience familiarity here, who's familiar with NiFi? Okay, great. So we have a lot of either current or future committers in the room. That's fantastic. Anybody familiar with Minify? All right. So who am I? I am a committer. I'm on the PMC for NiFi. My day job is I work at Cloudera, and I run the Data in Motion Engineering Security team. So out of all the DIM engineers, I am the DIMist. I do travel around and present at conferences as well, but most of my role is in research and development as a coder. And then I also work on bringing some embedded hardware and IoT integrations into a brewery that I work for. So boring stuff during the day, cooler stuff with IoT at night, in my opinion at least. So what is data flow? Right? Data flow is a very simple concept. It's moving bytes from A to B. Okay? We call the things that produce those bytes producers, and the things that consume those bytes consumers. And oftentimes they are technical systems, but sometimes they're people. Right? We can't just assume that it's always going to be some follow-on system and a chain 8 systems later is when arbitrary data gets generated or destroyed. Sometimes we need to present this in ways that make sense for humans to understand. And I think that a lot of times we forget that and just say, well, I gave it to you in that format, you should be able to use that format. The content that we're moving around, the bytes that we're moving around, it really doesn't matter what it is. It could be arbitrary bytes. There are times where it's going to be nearly empty. There are going to be times where it's gigabytes, terabytes, petabytes of data. It could be anything from text in a variety of formats, images, video, telemetry, sensor data, all kinds of stuff. And so I think one of the challenges around presentations that I sometimes experience in the audience is a lot of very nebulous or ambiguous terminology and theory, and it's hard to put that into application. All right. So I just want to give a few examples to start off with so you can understand on a base level what is this actually working with, right? What are we talking about here? So in a healthcare industry, a lot of stuff I work with is bedside patient monitoring, right? So hopefully nobody here has had a serious situation, but I have. I've been in the hospital for a long period of time, and I got to be good friends with the machines that were next to my head. Reading pulse, heart rate, blood pressure, oximeter, like all this kind of information. And you're getting all that information out of these sensors and feeding it back into some kind of centralized system. Well, it's generally going to have some kind of unique identifier about which bed it's connected to, but it doesn't really know anything about me, Andy Lopresto, all right? Somewhere in the hospital, there is a patient record system that does know all about me, and the most important thing, what kind of insurance I have, and then all the other things about me, right? When those two streams of data get joined, they give you a lot more information than if you only have one or the other, right? If you're reading blood pressure monitor and you don't know whether I'm a 75-year-old woman or a 4-year-old boy, you could get some really different readings off of that, right? The same data might give you some really different insight and help you determine whether or not to take certain actions. It needs to be secure, obviously. It needs to be auditable, and it needs to have alerting capabilities. So let's go to another example of manufacturing, right? I have a factory floor, I'm building cars, and I have assembly robots that use OPC UA as a protocol and handle all this information in and out. At the same time, I need to have high-level safety checks, right? I need to make sure that the robot isn't going to start swinging an arm and throwing molten steel at somebody. I need to have alerting, I need to have auditability, I need it to be secure. Another example in finance, right? I have some system that's feeding credit card transactions into a machine learning model that my data scientist built, and that's going to do fraud detection, it's going to do all these great things. Well, how do I get data into that? How do I get data back out of that? I need it to detect and filter maybe adversarial transactions that I stole somebody's card, and I'm going to try and make transactions that look like their day-to-day experience so I don't get detected. Or I open up a bunch of different credit cards, and I start making transactions that normally would be anomalies, right? They would be detected by an ML system as anomalous, but I'm now feeding adversarial data to say, I want to establish this as a legitimate pattern so that it doesn't get detected when somebody else makes that transaction. So again, it needs to be secure, it needs to be auditable, it needs to have alerting built in. So I don't think any presentation is complete without an XKCD. This is the most recent one that fits this. Sadly, a lot of XKCDs fit the problem that I'm talking about. Building these data pipelines or data models or data flows has existed since we started collecting data, right? This is not a new problem. The issue is that people often build a bespoke system that works with the data that they have at the time they're building the system. Raise your hand if you've ever started a project and ended that project with the same requirements. So you start building a system given the sample data that you have, and you say, okay, well, I've never detected a value of X for this column, so I don't have to worry about X. And then 3 years later, that system only returns X for that column. Well, now you have to rebuild your entire system, right? So we have challenges around managing data flow effectively. And I'm not going to go through everything that's up here. By the way, all these slides are available, so you don't have to take notes unless that's the best way for you to learn. But as far as data goes, we have all kinds of challenges. Formats is one of them. I'm assuming that a lot of people in here are data engineers, data scientists, software engineers, write code in some capacity or have the capability to. Raise your hand if you got into this industry because you really want to write a CSV to JSON converter 17 times over the course of your career, right? It's a solved problem. Why should you have to keep doing that? You work in a genomic processing facility and you're trying to fight cancer. Like, your day should not be converting CSV to JSON over and over and over, right? That's not really entertaining or exciting for anybody here. For infrastructure, I say this with the caveat that I am a security person. I run a security team. The one that I've bolded is my favorite, overcoming security, right? I think it's really important to enable security and make the systems be secure. But if the thing that I'm trying to enforce is a checklist, and I say you're at 89% and I need you at 90%, and I'm not going to let you deploy your project until you're at 90%, and that takes 6 months. Is that really helping you? Is that really helping us as a company or an organization, right? Just having that checklist isn't actually doing anything, right? Common sense has to be applied. So overcoming security is a huge issue, and I want to make software, and our team wants to make software that helps you do that. But then finally, let's say that we got rid of all the data challenges and all the infrastructure challenges in the world. We are people, and people still have challenges, okay? How many people have been in an organization where it was never really written down on paper, but there was always that team that was just hard to work with, right? And you send the data that you're supposed to send to them, and their network application is always down, and they don't receive the data, and they go to you, your boss, on Monday and complain that you weren't sending the data over the weekend, right? There are requirements that change, there are consumers that change. We've got this data science team, and so all the different organizations within the company are going to send our data to the data science team, and they're going to build these awesome models and give us all these really cool insights about what we should be doing. So that's awesome. And then we get a new CTO, and they want to put their stamp on something. Says, okay, why do we have this data science team that's often an ivory tower? I'm going to take all of those data scientists and embed one in every team. So hardware is going to have a data scientist, security is going to have a data scientist, finance is going to have a data scientist, and they're going to get close to the edge and give us all these insights. This will be great. So we have to change the entire structure of how we report data throughout the organization. And then 6 months later, we get a new CTO, and they say, why are these data scientists not talking to each other? We should take all these data scientists and put them in one group so that all the data scientists can talk to each other every day, and we get all this great insight. So we got to change all of our data reporting again, okay? And if you build a system that's bespoke and only reacts to the input that you have at the time that you start gathering requirements, it's very difficult to continually update that and rebuild that. And also, for those 6 months in the middle, well, do we just not have the data that we were collecting and sending, right? Do we have to go re-aggregate that from all the different outputs that we had? If you have a system like NiFi, it's monitorable, auditable, and able to be rebuilt very quickly from the historical data. So that leads us into NiFi. This will be a little bit of a summary, redundant for some people, I think, because there is a fair bit of NiFi familiarity in the room. But as we move on, this is going to be a very short segment here. 1 minute intro to the NiFi ecosystem. We've got NiFi, we've got Minify, we've got NiFi registry. Won't really be talking about NiFi registry today. If you have questions about that, I'm happy to answer any of those. But starting with NiFi. NiFi is a server class or data center class application. It's very robust, it's very big, it's very greedy. It likes resources and it will use the resources available to it. It has a nice graphic user interface. Well, I think it's nice, that's an opinion, but a nice graphic user interface, a REST API allows you to integrate with literally hundreds of different services, okay? We'll go to the Minify stuff in a minute, but I just want to give a very, very brief overview of NiFi for anybody who hasn't seen it. So I'm very comfortable in this. I assume a lot of people in this room are very comfortable here. The people who have a lot of the domain expertise or subject matter expertise for understanding where data comes from, why that data is valuable and what it means, often are not comfortable in this interface. So what we provide is this graphic user interface where they have a simple canvas, they can drag and drop boxes, these processors, onto that canvas, connect them with lines, visually represent what's happening, abstract and encapsulate all the code and behavioral logic that's actually performing these activities, and allow them to see this in real time, monitor what's happening, and update it if need be. The origin of this is actually from the Department of Defense. This was a system that was built for collecting data from a wide variety of sources, and especially at 3 in the morning on Saturday in some watch operations center, you don't have 5 engineers on staff who can go start writing code and redeploying that if something goes wrong. But the data you're collecting might only be available one time and for a very limited window. So you needed somebody, usually an E4 airman, to be able to drag a line on the canvas when something goes red and drag it somewhere to make it green again. And that's all they had to know how to do. So, as I just said, benefits for end users, very non-technical users can still create flows visually and understand what those flows are doing. And it opens up the opportunity to a lot of people who aren't developers and engineers, right? We want to make that, we want to enable them to do something meaningful with the data that they're getting and to get data that maybe they weren't able to get before. Now, if you're here thinking, I came to ApacheCon, I want to see code, don't worry, there's plenty of code. It's very extensible. You can write all the code you want. You can write scripting language code. You can write core Java code. You can deploy your own NARs, Python, C++. We'll get to all of that. But I could see some people going, this is not nerdy enough for me. I wanted more nerdiness. A whole grocery list of features from NiFi. Don't worry about it. They're on the slides. You can look at them later. Ecosystem integration. I usually say on this slide, anything that's been on the Apache homepage in the last couple of years, we integrate with. But I'm at ApacheCon, and I know there's somebody in here like, well, my project's not up there. So a lot of projects we integrate with. It's very extensible. If you want to write something, a baseline processor can be as little as 14 lines of code. All right, extremely easy to write and deploy. I've got other presentations about how to write a custom processor. Those are available online as well. There are also a lot of functionality components here that don't have to do with any other external system, right? Encrypting text, routing text, parsing and formatting text, enriching things with local lookup, remote lookup, and then obviously reading and writing to generic database and file persistence as well. So I'm going to talk a few more times about this concept of a flow file. And a flow file is basically our atomic unit of data as it moves through the system. And a flow file is very similar to an HTTP request or response. There are attributes, which are key value pairs, Those are like the headers in HTTP. And then there's content. And that content could be anything. It could be empty, right? If you have some kind of signal flow file that just has attributes going around the system. But it could also be small pieces of text, JSON, CSV, arbitrary binary, a video file. It doesn't matter. On the left, we have a standalone instance of NiFi, and on the right, a cluster, which is really just a collection of NiFi instances that communicate with each other using a clustering communication protocol. Within a NiFi instance, you have a JVM. You have one web server, which is embedded Jetty. You have a flow controller, which is essentially your global scheduler, your thread that manages all the other threads. And that has any number of processors and extensions loaded and allows for, let's say, Hive integration or receiving an HTTP request over the API, et cetera. And then there are 3 repositories, the flow file, content, and provenance repository. Those are local repositories stored on the file system or in memory, according to your configuration. And there are trade-offs there, obviously. And the reason that those are separated out is that it allows for some interesting approaches to data persistence during a flow as well as before and after a flow. That allows for retrievability and auditability and even replay in the future, as long as you still retain the data. But it also allows for copy on write and write-ahead log mechanism. So with the copy on write, if I bring in a video file, let's say 4 gigs, and I start enriching that video file with latitude and longitude information based on the IP of the camera that I recorded it from, and I maybe start running a machine learning algorithm that does facial recognition or object recognition over the video file and starts adding tags. Well, none of those operations actually change the bytes in the video file. So in a traditional system, I might have 3 or 4 copies of that video file now because I've sent it to do 3 or 4 different things. And all those bytes are identical. I'm wasting all that time, not only reading and writing it, but also the space of storing it. Because I haven't modified the bytes, in NiFi, there's 1 copy of those bytes. They're obviously just the 1 copy, so they're the same as the video file that came in, and that's persisted in the content repository. If I start modifying the video file, let's say I downsample it and say, this is security camera footage, I don't need it to be in HD, I don't need it to be 60 frames per second, I want 1 frame every second. I'm now modifying those bytes directly. That means that it'll actually create a copy and only the new bytes will be persistent. So now I can actually go back and look at before and after and trace what was happening to that file at a particular point in time and see that represented graphically through the history of the flow. And I'll demonstrate that. I don't know if the sound is hooked up. There's a video.
Hey guys.
Hi, hello.
It's Dana. I'll be taking care of you today. If you have any questions about the menu, please let me know.
I guess I do have a question about the chicken. If you could just tell us a little bit more about it.
The chicken is a heritage breed, woodland raised chicken that's been fed a diet of sheep's milk, soy, and hazelnuts.
Okay, this is local?
Yes, absolutely.
I want to ask you just one more time. It's local.
It is.
Is that USDA organic or Oregon organic or Portland organic?
It's just all across the board, organic.
Hazelnuts, these are local? How big is the area where the chickens are able to roam free? I'm sorry to interrupt. I have exactly the same question.
4 acres. Give me just a second. I'll be right back, okay?
Okay. Nice. We're doing the right thing. I'm too apologetic. You are. I drove way too slow here today, didn't I? I'm so weird at that gas pedal. I think just moves the whole vehicle forward.
Right, so here is the chicken you'll be enjoying tonight.
You have this information. This is fantastic.
Absolutely. His name was Colin. Here are his papers, okay?
That's great. He looks like a happy little guy who runs around. My friends, other chickens.
They put this on TV because it was a joke, but this is not a joke in our industries, right? This actually happens. And I've gone to customer meetings where they go, I need to be able to trace every bit of information that's come in, what has happened to it, why it happened, who performed it. We can provide that. There's a feature of NiFi called the data provenance, all right? And this is, term provenance comes from art and wine and all kinds of things out of France, tracing the history of a particular piece of content. And in this case, it's data. We can trace back the history of every flow file, see what happened to it at any given point in time, rebuild a directed acyclic graph of those events, trace that through time, see how it interacts with any other piece of data, see who was performing the operation, and even replay that event through a new operation if we need to. So we'll talk very, very briefly about some specific applications of these processes. And we'll do that based on healthcare. That's one of the areas that I focus on. So you may not be in the healthcare industry, but how many times does this happen where you have different data in different formats from different sources coming at different data rates? You need to get all of that into a single storage system, and it needs to be normalized. It needs to be compliant with your data integrity, validity checks. You might have legacy sources where you can't just deploy a new piece of software and say, hey, now comply with version 27 of this protocol, right? It's coming out of some mainframe system that hasn't been touched in 30 years, and there's one person who knows how to use it, and that person has negotiated an astronomical salary because if they leave, the entire company falls apart, right? This allows you to integrate with that immediately and still build your new follow-on system in parallel without losing that connectivity. This is literally all you have to type in to convert XML to CSV, right? You pick, I want the input to be XML, I want the output to be CSV, and do I want zero record flow files? Sure. This is using inferred schemas. So every flow file that comes in with some XML content, it reads the element names, figures out which ones are going to be common across a certain number of flow files that have come in, and then gives you a CSV output where those are the header names, right? Same thing works for JSON or Avro or SQL. But all of that is done automatically. And if you need it to be more specific, if you have an explicit schema that it has to comport with, that's fine. You can change a flag and say, hey, use this schema. But in general, you want to take the data that's coming in, instead of blocking as soon as that data gets to you, you want to at least try and make something valuable out of it, right? Or especially if you're doing data triage and engineering, you might not even know what the data coming in is going to look like. Maybe it was over some brick wall to the other team that built it, and the API agreement was very nebulous. And they just start generating whatever data they feel like generating. Should we just reject all the data and say, nope, project doesn't work? We're going to have another big meeting with everybody in one conference room? Or do we take the data in, identify, oh, we're missing this 5%, this one column that they forgot to add, but we can still capture all this data in real time? Pulling from external sources, the same thing. The top example is running off of an Azure SQL database, SQL Server database. I don't have to configure anything. I tell it the credentials that I want to use. I tell it which database address to pull from, and I get all that data. I can do the same thing over HTTP REST API, same thing from an FTP server, SFTP server, from local file system, from HDFS. I want the takeaway here to be, we're abstracting the individual steps of acquire data, process data, persist data, so that if the requirements change tomorrow, you don't have to replace your entire application. You replace one processor on a graph, draw a new input line, and now you're up and running again. Enriching data, so like the example I gave earlier about the bedside monitor and trying to join two streams of data so that I can have more complete information about what's actually happening there. And then data protection. Encrypting data at the source, you can do that either with symmetric or asymmetric encryption, and that gives you some different advantages. Especially consider in an IoT environment where you no longer have physical control of your devices. You don't want to put a symmetric key there, right? You would like to put an asymmetric key and say, here's the public key, encrypt that data. They can't recover it, and it can only be decrypted by myself back in the data center when I have the private key. So you're all here to talk about Minify, right? Because Minify is the more important one, more interesting one, out at the edge, all the hardware, that's the cool stuff. So let's talk about the challenges around IoT, first of all. I can go through the whole list, but I think the example is actually a little more interesting. This is somebody on Twitter. The Roomba broke and their security camera broke at the same time. And they got an alert from each one. And it was because the Roomba ate the cable to the security camera. And so they both went offline. IoT is supposed to make our lives easier. It doesn't always do that. It's not there yet. But there is some really cool stuff that is enabled with IoT. And that's what we're going to try and talk about. So, Minify. Why build Minify? Minify is what we call an agent. All right. So when I talked about the server class software earlier, this is an agent class software. It's designed to run on embedded hardware, legacy hardware, systems that weren't really built to run another server class application, or maybe have a different role, right? It doesn't mean that it has to be small hardware. It just means that it's not where you want a large application running. So let's say you have a Hadoop cluster, 200 nodes, all big beefy machines, and you want to get some instrumentation and log management off of all those instances. Should you install NiFi on every single one of them? No, that's a bad use of that hardware. You could put a tiny little agent on there and have it report back logging and instrumentation though, and that's a really good use of that. So, key takeaway, NiFi lives in the data center, lives on a server, uses the resources that it has available. Minify, we want to try and push that out as far as possible and get as close as possible to where the data actually originates. And again, just summing that up, why build it? Well, the latest released version of Apache NiFi, 1.9.2, is 1.2 gigs compressed, obviously larger than that uncompressed, contains everything you need to run and integrate with any kind of service you've ever imagined, but that's not really a good thing to put out on the edge. You don't really need a UI on your Raspberry Pi IoT device or your IoT gateway to connect to some robot arm. You don't need to put extra hardware out there. Minify has no UI, has no exposed API, has, well, let me be clear, doesn't expose the REST API that NiFi exposes. Does have an API for communication back with NiFi. We describe it as a good guest. I'm not going to embarrass anybody by asking if you remember floppy disks, but literally a couple versions ago, Minify fit on a floppy disk. That's not a couple versions ago, like 1995. That's a couple versions ago, like late 2018, it fit on a floppy disk. So we're really trying to build small software that can be embedded or put on embedded systems. I said that at the Embedded Linux conference last month, and they said that was too big. Like they were not impressed with a floppy disk. They were like, oh, well, we don't really have enough space for that. So this one's called flavors of Minify, and I say flavors instead of versions because there's two things at play here. Versions are 0.50, 0.60. As time goes on and the software ostensibly gets better, the versions increase. But there are also two flavors. One is Java-based and one is C++-based. So the Java version was built for fast to market. We already had all these great processors written in Java, running on the JVM. We had a framework for scheduling, robustness, delivery guarantees, blah, blah, blah. So let's take that, trim away the fat, and make that available as Minify. That gives you very fast access to anything that runs the JVM, right? So Raspberry Pi, no problem. But that's not a long-term solution. We wanted something that would also work with, obviously, natively compiled systems. So Minify C++, which is now 0.60, 0.7, should be going out pretty soon. That's not a guarantee of timeline. This is ApacheCon, you all understand that. C++ built from scratch to be available on some of those much more restrictive systems. The graphics here, this is designing a flow in the NiFi user interface, and then what that would be represented as in YAML on the right. At the bottom, that's just to illustrate bidirectional communication between NiFi and Minify. This is both going over the site-to-site protocol, but there are other protocols to use, where in NiFi you have this command and control concept, and I'll get into that a little bit more later, but you build your flows, you run your flows, you build your flows, you deploy your flows to the Minify instance, which runs the flows. Graphical explanation of what I just said. Now we'll talk about C++ extensibility. So raise your hand if you love C++. That's kind of what our market research indicated as well. C++ is fantastic. It can run on very, very small environments. It allows you to play with memory at a level that no human should have, but it also has some problems as far as extensibility goes. Raise your hand if you love Java. I use Java every day, and I'm surprised to see that many hands go up. I also really enjoy Java. Java is perhaps a little bit more extensible, a little bit more well-known in especially the Hadoop world, where NiFi does a lot of integrations. So there are a lot, and also NiFi already has a lot of Java processors. So the Minify C++ agent can still take advantage of those processors through JNI, all right? So that expands the number of processors. You have like 14 C++ native processors, and the list might be a little small. You can check it out later, but they're all things that are very specific to edge devices, right? Get the IP address, get something from a port, read something from syslog, things like that. The Java processors could be anything from encrypting data to integrating with Hive or HBase or some things that you probably don't need on your Minify C++ instance. But raise your hand if you love Python. Java beat Python today. That's interesting. Okay. I don't love Python only because of the spacing. That drives me insane. But other than that, great language. With an execute Python processor, the Minify C++ can also execute Python script. So you can write arbitrary Python script, run that directly in the C++ instance, and now you have a wide range of behavior that's available to you. So we've talked about NiFi, we've talked about Minify, and they were both separate concepts. How do those two things interact with each other? In NiFi, you design the flow, right? You build the flow, you have a graphical user interface, you can see the visual representation of what's happening. You build the flow, you set the configuration values. You aggregate data from many sources. You can perform your routing, your simple event processing, your persistence into other systems. In Minify, you're receiving the flow definition from your centralized NiFi instance. You're running those flows to collect data, and then you can do very simple event processing, and you can send that data out for the more complex event processing or analysis. If you look at the bottom here, this blue and yellow, it's orange on my slides, but see how it's a gradient? This is really to drive home the point that it's not a black and white, left and right, hard line cutoff between the two, okay? There are some times where, I mentioned the Hadoop cluster, you can run Minify in a large EC2 instance or your data center instance, giant machines, full racks. It's okay to run Minify there because the role that it is fulfilling is a small guest piece of software that's just offloading a little bit of data. At the same time, let's say you're a large electronics manufacturer or retailer, and you have stores all over the world, and you have credit card systems that are wireless, integrate with a phone that you might produce as well, and you can walk around the store and swipe your credit card anywhere in the store, perform your transaction, right? You don't have dedicated point-of-sale systems. Well, do you want every step of every transaction to go from some wireless card reader all the way back to a data center that you have somewhere in Northern California? Probably not. So you could say, I'm going to deploy a particular server in each store, right? And that could be, it's maybe a little bit more robust than a laptop, but for our discussion, it could be a laptop. So I'm going to put a laptop in each store, and that laptop is going to run NiFi. And each of those credit card readers is only communicating with the in-store server that's right there. And then that server can communicate back with my large data center. And so it serves as a regional data center, right? I mean, it's a one computer, no resiliency data center, but it's a one computer data center. It's a regional or distributed data center. In that case, you're running NiFi, right? You could have the graphic user interface, so you can monitor what's happening and the flow of data, the volume of data, and all this kind of stuff in your store. You don't have to call back to a data center analyst to worry about that. So we're getting close to the end. Slide 35 out of 74, if anybody's keeping track. This is one of my favorite quotes. Oleg Shelejev. The S in IoT stands for security. Right. So what does Minify actually provide to you? Data tagging and governance. Anybody work with connected vehicles? All right, this story will be new to you then. So a lot of connected cars, airplanes especially, love to collect GPS data, right? That's really valuable information, and it helps determine all kinds of things. Like if my tires failed, is that because I was driving in the desert or in the snow or the ice? Like, there's all kinds of different reasons that you can get a lot of great insight out of this. Anybody work with companies that are based in China? I mean, I think we all do at some point, but I take your point. If you're in China and you collect GPS data, that data cannot leave the geopolitical boundaries of the country of China. So you can't just say, oh, I'm going to put it on AWS and then hope I'm okay. I don't know about anybody else. I try to stay on the good side of the law in this country, especially when I go visit other countries, and China is pretty strict about GPS stuff. So your decision could be, well, we're going to put on AWS, and we hope AWS figures out where to store the data locally, right? We're going to say, hey, closest proximity, but what if I'm on the border with Hong Kong, right? What if I'm on the border with Macau? What if I'm on the border with a number of other countries? And AWS says, oh, well, the Seoul data center is actually closer than Beijing, so we'll just put it there. I've just violated Chinese federal law. I'm not excited about that. So Minify can do this event processing at the edge and say, oh, okay, I collected this GPS data because that's what I'm supposed to do. But before I go send this to the cloud, let me check and see where I am and if I should be doing that. And I can say, oh, okay, well, I detected that I'm in China. Let me pick a server that I know is physically located in China. Or let me scrub the GPS data from the data that I'm going to send to the cloud, right? Let me encrypt all of this data. Let me redact certain pieces of data. There's all kinds of options that you can take, and that decision-making can be made at the edge so that you're never in violation of those kind of regulations. Same thing with security. So I mentioned doing encryption. Earlier I mentioned asymmetric encryption, so you can do that based on certificates where you're not exposing any sensitive information to the edge in order to do that activity. And then low latency decision-making, right? Being able to, we'll talk about it a little bit more later, but being able to make decisions using a wide variety of input without having to communicate directly back to some external system in order to make the decision. So whether that's based on network availability, whether that's based on latency and decision-making speed requirements, there's a number of reasons for that. This, I usually go into a connected car example about what happens in a crash, but this one I think is a little bit more interesting. For $17, I made a system where in your brewery you have kegs. Kegs are heavy. They're heavier when they're full of beer. They're lighter when they're not. So you have all the kegs hooked up to your taps, and underneath you have these force-sensitive resistors where you put them in a Wheatstone bridge, and they generate different resistance based on the pressure that's on them. So when the keg is full, I get this signal out. As it becomes less full, I get this signal out. And I can feed that in through Minify into a system that's showing all of the different beers that are available and have it automatically display, hey, this is maybe 5 pints left of this beer, right? If I was really mean, I could raise the price when it gets down to 5 pints left. But I can do that. I can also even put like a little alert behind the tap so that the bartender, if they're going to go over and it's down to the last one, they don't get sprayed in the face with some, beer foam. If you like your employees. If you don't, you turn that light off and then yeah. So this is using an HX711 analog to digital converter amplifier, and literally the pieces are available on Bang Bang, or there's a number of different sites that sell them. You can get them in bulk, you can get them individually. That's just a cool example, I guess. So this is a mock-up simulator of a healthcare monitoring system where it's got some environmental sensors and it's recording pressure, temperature, humidity, and then displaying that back on some e-paper displays. This is again using Raspberry Pi with Minify. An example of immediate alerting. So historical data is really cool, right? And we can get a lot of insights out of that when we gather large amounts of historical data from all kinds of distributed systems, and we run our really cool machine learning analysis on that. But there are times where historical analysis is not sufficient, right? So in medicine, there's a mortality morbidity review, and okay, if somebody dies in the hospital, there's a collection of people who get together and try to figure out what, if anything, could have been done to prevent that. And that's great. We need that kind of activity to make our systems better. I'm more interested in, can we figure anything out in the second or seconds where that data starts changing that we can save that person's life, right? So this is a very simple graph. It's 2 sensors. One on the top is collecting pressure, and on the bottom is temperature. And you can see that the pressure stays relatively even throughout the entire course of this, but the temperature changed drastically. And that's because I moved one of the devices over a fan, right? So the temperature around that was cooler than the other one. I can capture that rate of change, the differential in the rate of change, and actually start sending alerts on that immediately, rather than just going back to this later in time and saying, oh, this does look bad, I should have changed this. Legacy hardware, I think you understand. Edge protection. Okay, so I have a couple other demos I can go into. We're getting close to time, so I do want to make sure there's time for questions. So just we'll do one of these real quickly. Call it out. This is the audience participation section. All right, we'll do the credit card reader. So this is me in Australia with the big bag of stuff that made security get really upset with me. This is building a credit card reader demo for some people. So I've got, I'm going to swipe a card. That could be a credit card, it could be a Starbucks gift card, it could be a driver's license, anything with a magnetic stripe on the back. The Raspberry Pi collects that data, sends it back wirelessly over to my laptop. So component list, I had, the ID tech is the credit card reader itself. Other than that, pretty straightforward, some pieces of software and a Raspberry Pi. I built two flows. One flow is what's running on my laptop in the NiFi instance, and that's receiving this data, determining which data is encrypted and not encrypted, handling the encrypted data if it needs to, routing everything else to the same place, parsing that data, converting it to JSON, putting it out to a file. And on the Minify side, I am tailing this log file that I have the swipes going to as ASCII, and then I detect anything that looks like a credit card versus a gift card, and I encrypt the credit card data, and then I send it back over that site-to-site communication. So a little bit hard maybe to see, but this is a section of the flow where it's actually reading in that information, determining whether or not it's encrypted or not. And so if it is encrypted, it routes it to a processor which can handle that decryption process. Otherwise, it skips it. This is the Minify flow. So this is what I built and then deployed to the Raspberry Pi. And this is actually very verbose. It could really just be 3 processors. I added some stuff here for logging and generating test data, etc. This is the custom logic. So a little bit of Groovy that I wrote just to parse magnetic stripe data. That comes from working at a company that's what I was doing. There are libraries to do this. You don't have to write the code, but I just knew how to do it. So now I have it running on my Raspberry Pi, running on the MacBook Pro, running on the hotel TV. I feel like if you don't want that to happen, you should lock it down a little bit better. I need another screen for the Raspberry Pi. I didn't bring enough screens. All right. For the last couple minutes, I'm going to talk about what Cloudera offers as Cloudera Edge Manager. So there's a command and control API for NiFi and Minify, and that's available via ASL v2. There's also a reference implementation which is available, and that allows you to build that into your own systems. But there's also an implementation that engineers at Cloudera have made, which is optimized for building this in a way that you're managing hundreds or thousands of remote devices and handling agent classes and deploying to, geolocated here versus here, or physically located here versus here in a building, and having that attribute-based control over that. Specifically allows you to have that visibility into all those different agents at one time. And then this is an example of running a machine learning model at the edge. So we have a model, we've trained it back in our data center for input from hundreds or thousands of different devices. And then we can export that model as a snapshot, push it out to the edge, and actually run it on each of those Raspberry Pi or IoT gateway devices. And I'm getting the benefit of very, very low latency decision making from that machine learning model running without having to train it at the edge and have, if I have 1,000 devices, each model is going to get to maybe 70% accuracy. But if I train it in my data center with 1,000 different devices worth of input, I might get to 95% accuracy. I can get that benefit of the larger data set, push the model definition out to the edge, and still run that so each device is operating at 95% accuracy. I can continue to refine that as well, because even though I'm making the decision at the edge with whatever model snapshot I have, I can still send the raw data back and continue to improve the model's efficiency as well. So to summarize, moving data is hard. What does NiFi and what do Minify provide? Allowing non-developers to build and monitor systems to do this intelligently and do this easily. We want to extend the reach and the visibility around your data to the edge, to as close as possible to where the data is originated, and then open up new use cases and opportunities for you to do what you actually signed up to do with your life. All right? Any questions? Please feel free to get in touch with me by any of these mechanisms. If you scan the QR code, that'll take you to the slides. They're not up yet because conference Wi-Fi is awesome. And there is a URL there, though. It'll be put up, I think, later today. Yes?
I have a question about this command and control feature. Why isn't that some kind of sub-project, but a separate GitHub project? I mean, I understand about the enterprise thing, but,
Sure.
But why is it a separate GitHub project and not? Is there any reason?
Oh, so it is a separate GitHub project.
Yeah, but it's no sub-project of NIFI or something.
It is a
It's
sub-project.
just a random HTML Apache license project, or is it a sub-project?
So NiFi is the top level
Yeah.
Apache project. Minify, NiFi Registry, and Minify C2 are all sub-projects. Actually, and NiFi FDS for anybody who's a designer. So those are all sub-projects of NiFi.
So this command and control thing is a sub-project?
Yes.
Oh, then I got it wrong.
Yeah. Sorry. If I go back, I think the this link will take you to the, but it's just Minify-C2.
No, just gonna ask you if it's governed by the PMC or not.
Yes.
Okay.
Yes. Any other questions?
Can we consider our mobile devices an edge device for Minify, and can it be deployed to Android and iOS?
Yes. So can you consider your mobile device? Yeah, absolutely. And there is Minify Java that runs on Android, and there are libraries that can run on other mobile phone devices. That part is not so much a focus of the Apache community, so I don't want to get into too many details. But you can definitely run Minify on your Android device today. Yeah. Yes.
Does Minify require that you have an NiFi instance, or is it able to push to other things like Kafka or something like that?
So that's a great question. Does Minify require a NiFi instance, or can it run independently? It can absolutely run independently. You can have a Minify instance that never reports back to NiFi at all. It pushes directly to Kafka. It reads a log, does some transformation, writes out to another log. It can be completely independent. Unless you really love writing YAML by hand, you need a NiFi instance in order to build the flow, which you'll push and deploy to the Minify instance. But theoretically, you could do that on your own. You don't have to have a NiFi instance to do it. It's much less fun if you do it manually.
Minify runs on Arduino?
Yes. Anybody else? Am I ignoring this side of the room? No questions?
All right, I got one more. In the financial world, we have to do like the old mathematical things and show your work.
Mm-hmm.
Is there a way for us to extract the metadata about the flow so that we can put it into with the data itself on there? Like it went through this step, went through an SQL, moved HTML. We don't need the whole UI. It's just searchable metadata that can be extracted and moved out. Is there a way to do that?
Yes. So my recommendation would be at the last step of your flow, wherever you're going to persist it or have it exit NiFi control, use an update attribute to put a particular, if you're using the NiFi registry to version your flows,
Yes.
you should be able to call an API, retrieve the version ID of that flow, and I would put that as an attribute on the flow file as it exits.
The whole flow.
Yeah. So you could say at time X, this piece of data, this flow file went through the flow defined by this version ID, and then later you could retrieve that from the NiFi flow registry and say, here's my exact, canonical representation of the flow at this point in time. And usually the NiFi provenance is retained for a certain amount of time, but for long auditability, we would recommend exporting to something like Apache Atlas for governance control. So we have a reporting task that can push the provenance data directly from NiFi into Atlas. All right, I think I'm just about over my time. Thank you very much. No, I'll say.
Then I can.
Yeah.
Excellent. Then probably. I have nothing.
Eu acho que ele faz.
Well, feel
You
free
have
to go fast because the speaker reception starts in 6.
Yeah, just learned that. So
Yeah.
I've
No questions. Catch me later.
I've tons of slides.
Yeah.
Yes,
It's okay. I'm just teasing. Okay.
And yes, you're in the right place to come up with to do with me.
I like to stay out of jail, so.
No, I mean,
Yeah.
This is my partner in crime from
I'll be right here.
Oh, for you, but I guess it's becoming pretty familiar now.
I think they have no.
Pretty late now. Just see, we have to finish small presentation for IoT DB, because I'm participating in Shark Tank.
Yeah. I think I can finish a draft, text draft tonight. Okay.
Yeah, I mean, Roman wants it today, so I mean, I will just copy some of the slides from tomorrow. I mean, and so I just wanted to tell you, I mean, I have to copy some images for 5 minutes. We just have to tell how awesome IoTDB is. And it is. I mean, it's kind of like Influx DB, but better.
Yeah, of course. But it's before we developed IoT, we was having a
There's so much. This is something I wanted to discuss with you. There's so much potential, I guess, in IoT. Okay. I mean, everybody's using the Influx currently because there's no input. But everybody would love to switch away from it, I guess.
How about tomorrow night? After that,
Yeah.
finish our talks and
Yeah, exactly. Tomorrow, Shark Tank is finished. The talk is video. They were like 3 people, kind of. Yeah.
So, how to say your last name?
Oh, just say my first name.
Okay, Julian. Julian is Julian.
Yeah, I mean, we're not so formal here.
Definitely good job. We have some.
I guess most of the people that stay here are first. I guess it's time.
Yeah. Yeah.
Did you already? I just collected the IoTDB swag. Did you already? It's awesome. Are you in here for Yeah, cottage. Because I mean, it's all the projects I'm kind of involved with, but it's really interesting. You are.
I'm telling you, it's
Oh, yeah, excellent. Yeah, if we do it that way.
That's all much.
Yeah.
Oh, yeah.
Yeah, I mean, I already have some.
Yeah. Okay.
I know you know some skipper.
Nice to meet you. You know Joe? I do, yes.
Yeah.
Tell him I said, I heard that.
Hey, this is my shot.
Sorry, nice to meet you.
My partner in crime.
Yes, I'm here until.
At least that's before we only had
Yeah,
like
Eric has
a handful of people
shoot
who
me a message.
know at least.
Perfect. Nice to talk to you.
We'll let you get to your thing.
Hey, what's your Twitter handle?
It's at jfinehour2.
At
Whatever reason.
J Y. Oh, okay.
Oh wait, I mean you followed me like a.
Oh shit, that's right. Well,
So, yeah, but just start typing.
there it is. I see it right there.
Oh yeah.
At J.
Yeah, exactly.
What?
No, without H. Just A. U.
There you go.
Yeah, damn.
Cool.
Excellent.
Thank you.
Julie, I don't want to block you from, when do you start that?
At half past, I guess.
Okay,
So it's
I got 2 minutes.
3 minutes, yeah.
Okay.
It's fine. And I guess it's a bit too long the schedule for the first day, probably 4 days.
What, till 5:30?
Yeah, I mean the schedule's planned till 6:20.
Or yeah.
I mean, in
Yep.
terms of other people there just stay just for kindness because they know.
Yeah. Well, and yeah, and like I say, because if I wasn't doing the recording, I'd just leave halfway through.
Yeah.
The thing. But that's fine. I'm gonna have to talk to someone about recording tomorrow afternoon because my flight leaves at 6:55, and this doesn't get over till 6:30 again. So like, I've got to get out of here.
Yeah.
But I think Bob Holland, I think I can get to do that for me, so it should work.
You know what the problem was? The Wi-Fi here sets the IP range to 1010, the net mask 00 for the last two, and that was coincidentally exactly the one I chose for my fixed IP range.
Womp womp.
Just speak 20% faster than we can hear.
Yep. Yeah, he knows. Heck yeah.
Well, let's skip like half the slides. Nobody will notice.
I don't think anybody's gonna gripe. Were you in the army or military?
No, so the project came out of DoD.
I know I saw that, but you were talking about like the E4 airmen. Like I don't know. It just
Not in a
implied.
bad way.
That's fine.
No.
I didn't know if it implied maybe a little bit more familiarity, and I saw the bag too. So
Yeah.
that's what.
It's actually I got this from my brother. He was a Marine.
Oh, okay, got it.
Oh, thank you.
Yeah. Okay. Let's welcome Julian to introduce the Apache agent project to us. Welcome.
Yeah, first let me say that I really appreciate everybody staying here. Thank you. I will try my best to make it a bit faster that we can finish off, and I mean everybody is speaking. We'll also go to speaker reception. First, I have to introduce a change of title. I mean, we started off with the title. There's life in the old dog yet. Apache Agent reinvents itself in Edge Analytics, but we slightly had to change the title to some awesome paint skills. There's no life in the old dog. Apache Agent retires itself, but that doesn't hurt Edge Analytics.
Oh.
Basically, this will lay the outline for the rest of the talk, and I will try to explain a bit why we consider that this is the right discussion, the right thing to do in this situation. Shortly introduce myself. My name is Julian. I'm married, have about 2.3 children. What's the point 3? Well, there's one in the making. Well, I mean, I'm holding a PhD in mathematics. That explains the pedantic. I founded a small startup company in Germany, and I'm pretty active in this Apache IoT context. So a lot of the projects like Edge and PSA4X, IoTDB, I try to be there. I'm active in the incubator, helping like projects in this range. Yeah, what I really want to talk about shortly is like edge computing as we see it, with a special focus on industrial applications. I'm from Germany with a lot of machinery there, machine builders, a lot of classical industry, and how Apache Edge can fit it in there yet, and how it probably will be in the future. So this is like the main outline. Let's go skip some of those things. I mean, this is a slide that probably all of you know. I mean, we have a lot of stream processing frameworks at Apache, and there's even new ones coming up. Let's go over to the industrial Internet of Things. I mean, we've heard a lot about IoT, but this is IIoT. So really there's an industry in it, big machines, big halls, like the real stuff. And things that are different there are that our sources basically are PLCs with hundreds of internal variables. So it's not like, okay, we have one sensor saying one thing, but no, we have hundreds of sensors saying things. We have totally different data types. Usually they come off of the machine without a scaling, so you have to know, oh, this one has to be multiplied by 10, or this one. I mean, come back from a time when there was no native float implementation, so they had to use integers and some kind of offset scaling. And we have tons of actors also with different technologies, so we really have to store metadata about it. It's not just knowing, okay, this is a simple value. We have to know, is this a motor or is this, I don't know, valve or whatever. So, and the next thing regarding stream processing, there are no discrete events. So it's not like fraud detection with credit cards or stuff where I just want to know if there's some anomaly or so. But it's really time series. So the events come in a certain order, or we have to order it and really have to know, okay, when did the pressure jump up? I mean, or when was a specific event? So events have to be extracted to start working on within my stream. Sometimes this can be done on absolute values, like, okay, we passed a certain temperature level, but also on other triggers like a bit switched on or off or something. But even complexer cases like derivatives, like, okay, I see the pressure decreases with a certain rate, so we know there may be an issue with the valve or something. So this is really what we consider in this context of this talk as stream processing at the edge. So it's not about bringing, as Andy would say, flow files from A to B, but it's really about doing something with them. So a simple example is such a machine. It's a machine from one of our customers, a pretty big machine, which is used in the foundry. And we start off with cycle detection. So they're like, okay, we want to know how many parts the machine does each day. And so we start off with pretty simple code. I mean, this is something we could write in basically every of those stream processing frameworks we heard about today. So it's just, we say we basically get a value each time, and then we see, okay, it has the same value as the last one or not. And if it goes from false to true, then we know, okay, there's another cycle done, and we store it, and that's it basically. And then customers usually like, oh, okay, but it could be jittering, so only if the cycle's longer than 10 seconds. Well, but no issue, we're coders, so we just add another if statement here. Okay, everything's fine. And it's like, okay, but when the cycle stops, we need to store the pressure because we know there's an issue or something. And then we're like, okay, no problem. We just add something to the event here, and I mean, you get a point here. It gets more and more complicated with every situation. Then something's like, okay, we also need some other values, and this is the point. I mean, we've been there many times. This is the point where we're like, wait a second, what are we doing here? I mean, it feels like reinvented the wheel. Code is basically every time the same, but especially this kind of code is extremely easy to make it wrong. So many switches, if statements, things like this are really, really hard to do. Usually you should do like, I don't know, 10 unit tests for all this stuff, and it's just annoying. And then there are even other more complex examples where, like, okay, we need production parameters at points, but you have like chains. First this bit has to go off, and then this bit has to go on, and this thing has to be done, and I mean, do this plainly is really, really hard. So this brings me, I mean, and we have all these stream processing frameworks, but they don't help us in this situation because they're just helping us with bringing things from A to B. This is a small comparison I did with, I mean, stream processing is not stream processing. We have many nice frameworks that focus on the cloud and have nice things like they can be scalable, distributed, they are reasonably fast and stateless and all that stuff. But at the edge, we basically do not need any of the properties. I mean, it doesn't need to be distributed, as we have one edge device, so no need for distribution. It doesn't need to be scalable. Speed is no issue because we're in process. So we will always be like 10 or 100 times faster than at the cloud. So this is just simply no issue. And we're usually not stateless. So we really, really stateful for the reason I just said, because these are streams, we have context. And also this message delivery thing, I mean, in the cloud you have applications where you need exactly once, but at the edge, because you have order time series, at least once is usually sufficient, because if you reach the mark and it comes back again and you can discard it with no issue. So those things that all those frameworks I've just shown, all the things those frameworks solve don't help us with our issue. So what I would like to do, and this is a previous example, what I rather would like to do is to be a bit more declarative, to say, okay, if a trick, I mean, I don't know, probably not really that good, but if a strategy which says untrue, I should trigger something. I have a handler which says, okay, it's an extractor, so please extract a field called pressure field and forward it as pressure. And this is something we have done at our company. Basically, we started writing such a framework, stream processing framework, we would call it, analytics framework for industrial applications. But it is really not a stream processing framework, something above. So basically, it's something you package inside your map method or your flat map method or whatever in a streaming framework. We open sourced it, I think, last year, and we considered that it might be interesting in context with Edge and our stuff, but we finally decided, this is like hot news from one day ago, we finally decided that it will be a sub-project of PLC4X. And I will say something about the reason behind it. I mean, PLC4X has been named so many times today, so no need to explain something, but PLC4X is like one major source where those data sets come from in our context. So let's say something about edge computing and then about edge. So in the end, if you do edge computing, you end up with some kind of idea how to do it. And I mean, you probably start with some best practice, the lambda architecture is what everybody knows, and it's like, okay, I can do it. And in fact, we also did it that way. Like, we have a Kafka instance running, and we did not use Storm, we used Flink, in fact, but yeah, and then you have some kind of database all running on a Raspberry Pi or something, or on a local PC, which just feels weird. Yeah, and then even you need some kind of cloud connectivity, which you can integrate into, and this is basically what the Edge project wanted to solve. So the idea was to have some kind of framework. They call it an Edge runtime, which has a nice syntax and which is capable of doing real-time analytics, and this is an important fact, and has also cloud communication integrated into it. So there's this picture. So the idea really is to have Edge, which is kind of the I mean, it's in that sense really also like a streaming framework. You just get things inside via different protocols and probably do something or push it out to somewhere else.
Maybe explain. Edge was previously called Quarks.
Oh yeah, you have to tell exactly. So perhaps I try to do it reasonably fast. So Edge was called Quarks before, and was basically given to the incubator by IBM. And IBM suddenly, 1 year ago, 1.5 years ago, suddenly decided to no longer contribute to Edge, and Edge basically was that day. I mean, there's one guy was left over from the PPMC, which is Chris. Chris then took me on board, so basically we're the only two like responding PPMCs of the project, and we thought that it's nice, because it's one of those building blocks you need in this IoT thing, because you need something, and using Kafka and Flink's not the solution, obviously. And I mean, here are some examples how ideally it should look like. I mean, there's also this concept. I followed this command and control thing pretty closely on Minify, because this is also something which was kind of integrated in here, which is something you need, because you need to communicate with these devices. And then there's really this idea that you can build your streams here. But and I mean, also this edge to cloud thing is pretty important. I mean, I've copied over some screenshots from all major cloud vendors, and everybody has this framework, which is oftentimes partially open source or probably a complete open source framework. But everybody has its own API. Usually it leads to a vendor login. I mean, prices are pretty cheap nowadays, but you can't rely your full solution on that, because then it will become expensive. And the entrance barrier is obviously pretty low, but as soon as you're in, then you won't find out that easy, I guess. So this finally, when I submitted the abstract, this is basically what we planned. We had this mission to really repopulate Edge and add some more integrations like the PLC for X integration we have. I plan to do an IoT DB integration, which is one of the other hot projects in the IT space, and really repopulate this thing, bring people on board. Yeah, and also integrate, as I said, also integrate the country memory. But it turned out that there was too few interest in the project, and I really have to admit, when going through the code, I went to the code base multiple times, and I would say lots of stuff that has been done there, probably from 2014 or 15, is just obsolete nowadays, because there are projects like Minify, for example, which give you basically everything, and all you need in this context are just some processors, one would say, or use the AK framework or whatever's out there. So the matter of how to bring basically values from A to B is no issue nowadays. It's more about the context. And there are other projects, even like Camel probably would make sense in more complicated scenarios. So basically, I mean, I had this talk 1 or 2 times. We planned to do a meetup. We wrote several mails on the list, and basically we concluded that this approach failed. So there really is no space left for action. So what we observe, I mean, this image from before, and what we see is that there's quite a vibrant landscape growing in Apache, and we have projects like IoTDB, which are the ideal like data layer. We have projects like Crunch, I just told you about, which is a nice processor in that sense, and we have projects like PLC for X, which of course is like the gateway. I mean, regarding cloud connection, there currently is nothing directly, and I'm unsure if there's really something similar to what Hadoop will do, because usually this thing happens then in the cloud, this static analysis. So basically what we decided what's next with Edge is to retire. I mean, this is like the unofficial announcement because it's not on the list, but later on we will write it on the list. There's that formal vote on it.
We have to find a third vote.
Well, Justin will jump in, I guess. If someone wants to join the PPMC, then
just to help put it down.
Oh yeah, yeah. So basically, it will be there. Yeah, so basically, this is not like the official announcement. So it's not, yeah, we have to be sad for a second. Yeah, but what do we want to do here? I mean, this topic is hotter than ever. So there's no point in simply discarding it, but what we really should do, and it not only Agent, but we as the IoT community, and therefore it's nice to have the IoT track here, is find a way to integrate the modules that we find worthwhile in the current Agent code to other projects. For example, the cloud connections is something I would like, therefore I'm happy that you stayed here. I see many things could go to NiFi or Minify. I mean, Chris has some issues with
cloud connectors, so we have one.
Excellent. It's less work. I mean, I guess there are even some, I would guess. Yeah, and it really comes basically up to the decision if we think there's a need for such an integration project like Agent was, or if we find some PMCs which basically help us take out the building blocks of Agent and just give them like new homes, that we as developers are able to get everything together to have a nice stack to build solution. It's about a stack. And if we consider that there would be a need for something, then we should really consider do it as a sub-project in an existing PMC, as NiFi, for example, does it, or now we will do it in PLC for X, because it's really an important thing. And I see this in the IoT. We see this with several projects in this IoT area, that we have many projects in the incubator, but it's sometimes really hard to form a working PMC out of it. So we should really concentrate on this community aspect, not just on hacking some code that works. And one specific example for this is that there is this mailing list. We found it, I don't know, half a year ago or something, or 3 months ago.
3 months, yeah.
It's called IoT at apache.org. This is something we said we should have some central place where we could gather all those people from different projects. There are not that many people involved yet on this list, but I would really like to see it growing there a bit, and this could kind of fill at least one or two of the gaps that Action probably leaves, that we work together from these different projects. Perhaps in a way, it's, I mean, we're at ApacheCon, but I really like this concept how Eclipse does it with like their sub-project level. I mean, it's similar to the IoT track we now have. So, and this is like the list for it. So I would really like to see people coming to this list, discussing things, how we can integrate those projects, because no project will solve it all. And we should rather concentrate on integrating things and building solutions off of it than to make like another project, which, I mean, there's this XKCD comic about these standards involving a lot of standards and stuff. Yeah, so basically, this is it. I've done it as yeah, as fast as possible. I try to make a quick one. I mean, we can have some discussion. You can also go over, drink beer, and have some more discussion. But the key take is really, action is that, but well, nobody cares, I would say. But yeah, well, if we would have cared, they probably would have responded on me. Some of this no, but really, I mean, what Action did or wanted to do is a good thing. So we really should find a replacement for that, but in a working way, and not on, I don't know, 1,000 lines of dead code or 10,000 lines of dead code. So this is really a takeaway. So therefore, I like that we're close to the Minify NiFi project, because many things are there already, like easy to use and all that stuff.
But Minify was C, wasn't it?
No,
There's a Java version and a C.
Now there's a Java version. Yeah, back then there was no Java version. Now there's a Java version. So
No, the Java version was first. The Java version.
No.
Yeah. Yeah, so the Java version was first.
Right.
We just took all the Java
Super awesome
processors.
if there was some Minify guys that sort of could get my integration module working.
yeah,
So
so
what
that,
I have to do for that.
I mean, perhaps a little announcement for everybody's here is that tomorrow there will also be a talk from the Stream Vibes guys, which also kind of plays in this area. So it's yeah, it's just about having a discussion. I really would like to see many people on this IoT list.
Yeah.
It's like officially the fastest talk of this Apache.
Well, to be fair, your project died after you submitted the abstract.
Very first, I've been to a lot of Apache cons, and I've never seen a funeral.
It's also important.
No, it was good. I think you're right. I mean, there's still work to be done, and it's awesome that the two of you are there. That like you pick the corpse and get everything that's good out of it. I've seen some projects from my glorious employer, and they tend to definitely be code heavy and just kind of fat. So I get what you're saying on the 10,000 lines of just code.
Yeah,
that
the problem is generally that sort of there is no, some decisions were made, but we couldn't find where the reasoning behind them is documented. It's sort of, there were very strict rules in the build, because that was how I got involved. They had the agent build that really sucked. And me being sort of the mavenizer, sort of cleaned up the build so they were able to release. Yeah, so, and after I finished the release, they released, and then IBM released. And it was sort of just me sort of being the first non-IBM PPMC, and then everybody just left the party, and I was there, so come on. So now let's get started, and everybody just went away. It's sort of, yeah.
Well, I'll jump on Edgent to help you vote and clean things up, but I need some Maven help on Mahout. So
oh, excellent. Let's join the PPMC to have like 10 binaries.
and that's how Edgent accidentally bounced back.
I see a new Apache shared service. Maven build helper.
Should be a project for that.
We'll fix builds for beer.
Okay.
I'm gonna shut this down. Are we good?
The builder template that you, the builder code template that you had for doing the detect the cycle end and.
Yeah, this is basically the Crunch framework, which is currently on GitHub.
Yeah.
I integrated the GitHub link there.